Hello, my name is DJ Lewis and this is Lab 5, Earth and Mars. The purpose of this lab was to model the motion of Earth and Mars around the Sun using Newton's second law. More specifically, to predict the length of a year, month, and day on Earth plus the period of revolution of Mars with respect to the Earth and the Sun. Furthermore, to compare real and modeled motion data. My results turned out to be fairly accurate. The model predicted year was off by 2 days, and the modeled Earth month and day were nearly spot on with 30.223 days and 1 day, respectively. Also, the modeled period of revolution for Mars was 1.87 Earth years, similar to the actual data of 1.88 Earth years. Here are my governing equations. I assumed the force of gravity was the only force acting on my system. Therefore, F net equals the force of gravity. This net force was used in Newton's law to update the velocity and position of both planets over time. This is the actual data I used to compare my model's predicted motion. In order to model the motion of the Earth and Mars, I used VPython. Here I created a display screen to show the Sun, Mars, and the Earth over time. Initial conditions such as the mass and speed of each object were found online. It's important to note that I chose to begin my model with the Earth and Mars directly above the Sun, so the initial velocities of each planet were only in the plus x direction. For my small time delta t, I chose 1 Earth day, or 86,400 seconds. In order to calculate the velocity and position of each planet over time, I used Newton's second law. Here you can see I calculated the force of gravity acting on each planet by the Sun and used this as my net force. With this, F net, I used Newton's second law. Next, I found the time in Earth days to complete one revolution for each planet using the equation 2 pi r divided by v divided by delta t. These values were used to find the time in days for one Earth month, day, and period of revolution for Mars. The period of revolution for Mars was found by dividing the time it took in days it took for Mars to complete one revolution by 365 days. Here is the model I created. Earth is the blue sphere, Mars is red, with the Sun being yellow. Notice the orbit of each planet is circular as opposed to elliptical. I will discuss this in more detail a little later. Recall the actual and model data values. Again, my results were fairly accurate, but why were they not exact? Recall in reality, planets orbit in an elliptical manner due to different planets' axes of rotation. For my model, I didn't account for this, thus resulting in a circular orbit. Consequently, my predicted data did not exactly match the actual data. Also, it is important to note that f of g from the Sun may not be the only force acting on the planets. For example, each planet could pull on each other slightly due to gravitational attraction. Thank you for your time. Again, my name is DJ Lewis. Have a good one.